Welcome dear students. Today's lesson, non-conventional energy resources and their future. Learning objectives. After studying the present module, you will be able to understand concept of non-conventional energy resources and its types. Familiarize with its uses and sustainable practices. Comprehend the scope of non-conventional energy resources in future. Introduction. The world energy environment is experiencing the paradigm shift as the world faces the two challenges of satisfying the growing energy needs and the sustainability of environment. The non-conventional energy sources have also been referred to as renewable or alternative energy sources, and this has come out as one of the key solutions as they are clean, sustainable and infinite substitutes to fossil energy. With more and more intense climate change and the depletion of conventional energy resources, the shift to renewable energy has become a necessity in sustainable development. The natural processes exploiting in non-conventional sources of energy are those that replenish themselves continuously, such as the radiation of the sun, wind, flowing water, organic biomass, the inner heat of the earth, and the movement of the ocean. Contrary to fossil fuels, which have taken millions of years to form, renewable energy sources have an unending supply and have little environmental impact. Renewable energy has become cost-effective and technically feasible to be used at large scale with dramatic cost savings of solar and wind breakthrough in energy storage and grid management. This module addresses the key unconventional energy sources such as solar, wind, bioenergy, the technological basis of these sources, geographical locations of these sources, environmental sustainability and prospects in addressing world energy requirements in the future. Concept and characteristics of non-conventional energy resources. Non-conventional energy resources are those resources of energy that come as a result of natural processes that are naturally self-renewable and that would take human time. These resources are radically different from traditional fossil fuels when it comes to availability, impact on the environment and their sustainability. Defining characteristics. Renewability. The non-conventional energy sources are self-renewed by the natural cycle. The sun is shining on the earth every day. The wind is blowing constantly, rivers flowing constantly, and biomass recycles itself by photosynthesis without worries that it will run out. Environmental sustainability. The technologies of renewable energy emit the minimum of greenhouse gases in the course of operation. Solar panels, wind turbines and hydroelectricity production do not require fuel to be burned. Thus, carbon dioxide, sulfur oxide, nitrogen oxide emissions are not produced. Distribution or availability. In the contrast to fossil fuels that have been concentrated in a few geological formations, renewable energy sources are abundant sources of energy that can be found in many regions across the world, which helps to increase energy security and minimize geopolitical crisis over the utilization of the resources. Low cost of operation. Renewable installations are economically in terms of operating cost because they need heavy capital investment in installations, though no fuel costs are incurred and minimal maintenance costs are incurred. Scalability and modularity. Renewable energy technologies are incredibly scalable with small household scale systems and gigawatt scale systems and allow energy systems to provide energy solutions that are relevant to the local demands. Technological innovation. The renewable energy industry is one of the areas that have witnessed a wave of unending efficiency, cost and performance. Types of non-conventional energy resources. Solar energy, radiation of the sun. Wind energy, kinetic energy of the motion of the air masses. Hydroelectric power, the potential energy of water and the kinetic energy of water. Biomass energy, organic substances by means of conversion processes. Geothermal energy, the heat in the center of the earth. Ocean energy, tides, waves, thermal gradients. Solar energy, harnessing the power of the sun. The most available renewable resources is solar energy. The sun pours efficient energy on earth constantly of the about 1,73,000 tetrawatts or 10,000 times the total energy usage of the entire world. Scientific principles and solar radiation. Nuclear fusion in the center of the sun forms solar energy. The intensity of the sun rays per unit area is referred to as solar insolation. Solar insolation depends on the latitude, altitude, weather conditions and the seasons. Conditions are favorable in the so-called solar belt between 35 degrees north and 35 degrees south with an insolation of over 1800 to 2500 kilowatt hours per square meters per annum.